Okay, so let's take a look at type 3 of the DI method. So type 1, remember, was when you have your columns like this, D and I, and the D column gets down to a 0, that's when you stop. That's type 1. Okay, type 2 is if you can, before a row gets to 0, and maybe the row is never going to get to 0, if you can integrate a little bit easier any of the rows, then you stop. That's type 2, and you integrate that. It might be something like, it might simplify to just an algebraic monomial or something easy like that. So the type 3 is when you have some kind of repeat. So you basically have a row that repeats the original question. All right. So type 3, and I'll just maybe type that down here. Okay. A row in the DI chart repeats the original integral. So this is going to be a type 3. So we'll just do this example real quick. So if we take a look at this, and if we remember Lie8, right, that's our little memory mnemonic as to which one we should put in the derivative column. So this is the order of importance, or the order of priority for a derivative. This is logarithms, inverse trig, algebraic terms, trig, and exponential. So obviously the trig shows up before the exponential, and of course e to the x is very easily integratable. So that's going to be e to the x all the way down, right? No problem. So we want to put a plus here on the first row, and we'll put sine x here. Okay, so that's the way we start, derivative column. So the derivative of sine is cos x. All right, now that's the first two rows. So is it any easier to integrate cos x times e to the x? Not really. So we'll keep going. So the next row is plus, and of course the derivative of cos is negative sine, right? Okay. So that's getting close. That's a negative sine x e to the x. Now that's interesting. That's very close to our original, right? Except we have this pesky negative sign there. But if you recall, what is the integral of negative sine x e to the x dx? This is a negative 1, right? Which is a constant, which can be pulled out of the integral. So really, in essence, we do have a repetition of the original integral in this particular row. So that's type 3. And I guess in a sense this is sort of a really close relative of type 2, because you look at a row and you can you easily integrate that row? Well, maybe not easily integrate, but you're going to see that because it repeats the original question, it's going to be interesting for the equation. So it's really closely connected. So let's just write this out. What we have so far, we just have a regular non-integral part of this solution, which is going to be this top one times the value on the diagonal, right? So it's going to be sine x times e to the x. And then, of course, this row is another just straight algebraic part, so we can keep going on the row. So it's going to be minus cos x times e to the x, all right? And now this row here, which I'll put in a different color, is our integral row, okay? So then now we're going to do minus the integral of, and I'll just rearrange the terms so it looks exactly like our original equation. It's no problem. You don't have to. But do you see what we have here now? We have this is partially solved. We still have an integral, but this, you see, this is on the left side of the equation. There's the equal sign, and then this is on the right side. Okay, so I'll just rewrite that really quickly down the bottom here. Okay, so here down at the bottom, it's all written out in one complete row. And here's the thing. We have this quantity here and the positive version here, and we have the negative version of the same quantity. So if we were to combine those, it would be basically we would have over on this side, if we added this integral to both sides, we would have 2 of these integrals. Okay, and then you can kind of see, and I'll factor this e to the x out maybe. But what you could probably easily see is that we're going to divide both sides by 2, and we are actually going to have basically an algebraic solution to this integral. We have no integral parts left over, and this is the question that we were asked to find, was the integral of this. So, that would be your answer, 1/2 of this, or all this over 2. And I think that's the answer. Again, does that look correct? Sorry? Thank you. It is, of course, thank you. We are done when we do plus c. I don't want to trip over that chair again. So when there's no boundaries, we have to do plus c at the end. Yeah, because there may be a constant that we don't know about. But that's type 3. Okay? So again, the 3 types again. And again, the repetition. It's very important for us to do that. So when the derivative column gets to a 0, you can stop, right? And then that represents kind of an end to your chart, and you can just write out all those parts. When you have a row that simplifies maybe and is easy to integrate with just a simple technique, or if you have a row that is an integral that's the exact same as the original question, that's another way you can stop, and that would be type 3. Okay. Any questions about that?
Sorry, last step, how did you get that?
This here?
Yeah.
So over here, so you add this integral, right, to both sides, and when you have this over here, there's 2 of them now.
Okay.
So the 2 of the same thing. So it's just like putting a 2 in front of this one. And then to get rid of that 2, you just divide both sides by 2.
Wow.
So this was like this before, and I did that. Okay? Yeah.